Thanks, Leon. I'm happy to talk to you today about my work in creating and deploying an early detection system for the citrus disease, Huanglongbing. So what is Huanglongbing? Huanglongbing is a deadly and incurable citrus disease that's spread by a flying insect, and it affects all popular citrus types. So think lemons, limes, and oranges. Catastrophically, HLB doesn't reveal visible symptoms for up to 4 years, and this makes it incredibly difficult to slow its spread. HLB's spread to commercial citrus has resulted in significant reductions in citrus crop yields throughout the world. In particular, HLB has reached epidemic status in Florida and has devastated the Florida citrus industry to the tune of $3 billion in lost grower revenue and more than 250,000 acres of citrus abandoned to date. HLB now threatens to imperil California's $3 billion per year citrus industry that produces 85% of US fresh citrus. Early detection of HLB would allow California growers the ability to quarantine and remove affected trees to stop the outward spread of HLB from its current location within the Los Angeles area. The currently employed method of detection is lab testing. This requires leaf removal from the tree and a subsequent test days later at an offsite location. The limitation of this approach is that it is not systemic. The insect that spreads the disease nests in very localized regions of the plant, meaning that at early stages, the disease is also very localized. Thus, if you miss affected leaves, which is likely, you will not accurately determine the disease state of a citrus tree. So what's required in a detection technology that will meet the needs of the California citrus industry? Well, based on numerous interviews with members of the California industry, we find three critical parameters. First, the technology must be highly accurate. Second, it must be timely in that it must be able to detect HLB just weeks after infection. Finally, it must be affordable to growers, which compete in a low-margin industry. We estimate a successful detection technology must be below $8 per tree per year to be economical to growers. So to put this in terms of an end consumer, an $8 per tree per year cost passed to consumers is equivalent to about a 3-cent increase in your $1.40 pound of navel oranges. To achieve these requirements, we are developing technology that can detect HLB at the scale of whole trees. Plants produce signature volatile organic compounds, or VOCs, during various stages of development, as well as during stressor events. So think of the smell of fresh grass clippings. That's a distress signal. For citrus plants, signature VOCs are produced when the plant is healthy, as I've shown on the left, as well as weeks into HLB disease, as I've shown on the right. As I've illustrated, these VOCs provide a cloud of detectable biomarkers around the plant. And so we are pursuing a whole plant method of detection. Gas sensors located near a citrus tree will be able to detect the production of asymptomatic HLB VOCs without direct proximity to the localized infected region. The reason that this method of early detection has not been implemented already is that currently available gas sensors do not combine all of the performance characteristics required for success in the tough environment of a citrus grove. These characteristics include a high sensitivity to HLB VOCs, small size, low cost, and long-term resilience to humid air exposure. However, we built a proprietary sensor technology that meets the requirements of this unique challenge. Okay, so we have the sensors that can operate in the conditions of a citrus grove, but we still need to line out a strategy for deployment. One very promising avenue is stationary detection platforms, which would provide continuous HLB status information of a citrus grove. Stationary detection platforms will be secured in proximity to a tree of interest, and at predetermined times, the device would complete 3 functions in sequence. First, a device would sense the surrounding air for VOCs associated with HLB onset. Second, it would process the data to produce a yes or no diagnosis of HLB disease state. Finally, the device would wirelessly report back this diagnosis to inform decisions regarding HLB disease mitigation. HLB begins its spread at the peripheral trees of a citrus grove, and so peripheral trees would be the focus for early detection. Thus, only a small portion of trees, we predict less than 10%, would need to have their HLB status determined in order to protect the entire grove. This significantly decreases our costs. Based on this fact and the low-cost nature of the underlying sensors technology, we estimate we could offer the devices as well as a detection service for under $4 per tree per year for an entire citrus grove, half the upper pricing limit of $8. So where to next? We've already validated the foundational technology, and right now we're completing prototype development. Next, we're going to pilot test in California, and finally, we're going to build a startup team to deploy this technology solution. Thank you. I look forward to answering your questions in the breakout sessions.